Not too bad.
Here's the setup, my first operation that I've got in the mill. Okay, and maybe for point of reference, let me divulge a little bit of what my vision is. Let's see. I think this is the whole fixture plate. I've divided up my whole plan into separate files for CAM, but I did all my CAD in one file. This is what it'll look like when it's done. Okay, I've got my base plate. These are the retention plugs here and here. And imagine some sort of lower die that those will be screwed into. This is an adjustable fence. Originally I was going with these handles here, but I went with just that, more of that lefty-loosey, righty-tighty design because I think these were kind of cost prohibitive, but you get the same idea. You can tighten and loosen this fence and bring it forward almost the center line of this, but there's no need to go that far forward because you're ultimately going to have some sort of work in here, I would think. I did design in this plug, this hardie plug here, and so I'll also have plugs here. So if I just want to use the surface of here, let's say I'm chasing a vein or a line, I'll be able to pull out this hardie plug, or sorry, I'll be able to pull this fence forward and then run that. But it is tall enough that, depending on what I'm doing, I'm also going to have a small anvil here that'll lock in that I can maybe use that fence with. We'll see. So there's the T-slot and the fence. Really, the guts are probably what's interesting here. And I've got to say, I'm doing this the most fundamental and basic way that I can think of, based off of my capabilities and the capabilities of my shop. I've tried to keep this simple. So I've got a bolt here. Tightening this bolt will tighten these retention knobs. Loosening it will release those and the die. Whoops. Let's see here. Here are the guts, or the back plate. This is probably the last video, or my last part of the project. I will be doing everything in here. So let's see here. So let me remove the cover plate, and then you can see kind of what I've got going on in here. As I tighten this bolt, it's going to push on these rods. These are 4140. I ordered or purchased precision round rod. Okay. So as I tighten this screw, it'll separate those two rods. This one goes right, this one goes left, pushing on their respective clamping rods, and then those will advance forward into the retention knobs. Okay? Whoops. No, I don't want to do that. And when I loosen it, these springs here will push these rods back out, push these back together, and then I'll be able to pull the knobs out and pull the die out. That's the general idea. Might not work, guys. In my imagination it works, but there is a chance that this might not work. So let me hide these components. And now you'll see what I have to get done today. The top op is easy, the bottom op is all of this cavity. Yes, these are square holes for round rods, but hey, it'll work. And then I've got to finish these island T-slots. They don't go all the way through, okay? So let's go over to the machining portion, and I'll show you what we're going to do. So here's op 1. I'll zoom in a little bit for you here. I'm going to do a spot drill. Okay. Then I'm going to drill with a 25/64 bit to open up these bores, these holes for where I'm going to do a boring operation for the 16mm retention knobs. Okay. I'm going to be drilling in. You remember this was a hardie hole, and the square sides of this hardie hole, it's kind of dog boned. It's, you know, I can't make square corners. I can make round corners. So I'm drilling out these 1/4-inch holes, right, in preparation for a 3/8 end mill to clear this out, and then I have just enough room to do my contour to make a square hole. And that's okay. That'll work just great. I'm going to be drilling fairly slowly, 567 RPM, surface speed of about 17 meters per minute. So that should be slow enough to drill that out. And I'm not too worried about that getting off center since I'm chasing it with a boring operation. So here's the boring operation. This is with a 3/8 end mill. I'm running this at 5,911 RPM, which equates to a surface speed of about 177 meters per minute and a cutting feed rate of about 1,868 millimeters per minute. Okay, I'm going down at 2 degrees, and I am doing it in computer. I have the retention knobs on hand, so I will be able to test fit that, and if need be, I'll go back in. I'll rerun this cam for just this with wear, and I'll sneak up on, I think it's 16.01 is the tolerance that I want to fit those in perfectly. I'm running an adaptive tool path with the same tool, same speeds and feeds to clear out this hole. I'm going down, I think, a diameter and depth, actually a little bit less, about 8 millimeters in roughing step. My machine, it's a 2020, and you know, I'm learning its capabilities, and I wish I could go, you know, 25 millimeter depth of cut and just run that out, but I don't know if it must be, I think it might be my Y bearing. My machine is just not that rigid or strong enough, and I'm tired of listening to it. I don't want to hear it scream, so this is what it is. It'll take as long as it takes. Followed up with a contour of what I bored, and this should be in computer, and I'm repeating the finish pass, so it's going to hit that twice. So after, yep. And this is what I would rerun with wear right here if I need to take off a little bit extra. And yeah, I'll run a contour in the hardie hole, and then I'll run a contour with a 1/4-inch end mill of just this top part. You noticed in the drawing up here, in the drawing before, I will have a plug here made out of 4140 that'll close this hole up unless I need it. And then the last op is a project operation. I'm running an 1/8 inch end mill right here. You know, branding, right? Brand everything. So I'll be running my maker's mark, the power symbol that looks like a G since my name's Garen. Let's let this thing catch up. And power forge, and then my manufacturing date, which we're in February of 2025. Okay, so there's op 1. After op 1, I'm gonna. Well, actually, that's okay. So, yeah, there's op 1 of setup 1. Since this is so wide, you know, my machining area is roughly from here over to here. I'm worried that I'm going to get an error when I try to machine the top side of this T-slot. So I've separated my T-slots into separate CAD and CAM. So this one is for the left. That's a 1/4 inch end mill, which I'll run in here. It's going to take a little while, 15 minutes. Contour, and then it'll chamfer all of this. It'll deburr. And then on the right side, this is where I'm worried that I might be too far to the right side of my machining envelope, and this might air out. If that's the case, I'm going to pull this off the 0-point plate, move it over 2 holes, get a new 0, and then run that. It'll work, but it'll just be a pain. So fingers crossed this is going to work. So that completes setup 1. Now on to setup 2. So setup 2 is the interesting part. Provided nothing goes wrong, I'll leave this as it is. If on the last part I couldn't hit the right side, I will rework this CAD and CAM to make it go smoother. I'll put it into 2 different setups. But I'm going to open up this pocket with that 3/8 inch end mill again. Same feeds and speeds. I'm going to go down in the same depth of cut. My maximum roughing step is about 8 millimeters. Okay? And I'm not going to leave anything on the floor. It doesn't have to be pretty. I'm going to leave 0.25 millimeters on the of radial stock. Okay, I wish those pop-ups would stop. I'm going to leave 0.25 millimeters in radial stock and then clean that up on a contour pass. Okay, then we'll go to the left T-slot, followed by the right T-slot. Then I'm going to go into with an adaptive, a 1/4 inch end mill, and go all the way down. It's quite deep, but I think I can make it. Hopefully there will be no collisions. Before I start milling, I'm going to just double check how much stick out I have of my 1/4 inch end mill before I run this, and make sure that my tool holder is not going to collide with the work. I'm going to go into my contours on my T-slots with that same 1/4 inch end mill. That way I don't have to do a tool change. More contours. Then I'm going to spot drill for the back plate. Okay. Then I'm going to come in here with a number 7 drill in preparation for a 1/4-20 thread. Okay. The number 7 drill I'm running at 1103 RPM, which equates to about 17.7 meters per minute. I'm running it with coolant. I'm doing some deep drilling. I'm doing a peck depth of 10 millimeters. It'll go down 10 millimeters and then come back up. And I am going to have, since I'm tapping, I'm going to let it dwell and spin for about half a second to improve the surface prior to tapping. I'll chamfer it, a nice, well, maybe not a deep chamfer, a 1/2 mil chamfer. It should be okay. I've got a semi-bottoming tap. Oh, chamfer. Oh, while I have the chamfer in, I'll go up and get everything else. And then I'm going to tap with a bottoming spiral flute bottoming tap. Right there, 1/4 20 semi bottoming tap. Running that at 3,300 RPM. I'm just running a tapping cycle. Go in and out. So there you go. There's the work for today. Not exciting. Might not be my most boring video, but it might be up there.
Okay. Wish me luck. Sounds pretty good. Here's the 1/4 inch drill.
done, I'm gonna have to run another aught. It's almost there. Won't take much. I'll have to run a little wear contour with wear to open that up just enough. Alright guys, so there are the main components. We've got the branding here that looks good. So the branding looks okay. A little 2D, but that'll work. And got the tops of the T-slots in. And I've got this already set up, and I'm gonna chase these holes with another contour so that the retention knob fits. But yeah, so far so good. Okay, this one I'm just running a spring pass without wear. See if that does it. that didn't work, I'm going to run it with wear. I'm going to start with a negative value of 2.5 microns, 3 microns, and sneak up on it. Stepping over at about 3. Sneak up on it. Oh, yeah. Okay, closer. Let's do some more. Alright, so let's go to tool wear. We started with -3. And bump that up to -6. And see if that makes a difference. A little better. Sneaking up on this is monotonous, but it's worth it. It's worth it to get it right. I'm just going to keep sneaking up on this little by little until it fits. Let's move on. Pretty cool.